Hey guys, tomorrow we're going to be working on a lab report for weight versus mass. That's our goal, that's our title. Our essential question, what we're trying to figure out is how is weight related to mass? How are those two things related? So that's your question. Your hypothesis is going to answer that. Now, some of y'all's hypotheses were not too great for the last lab. Your hypothesis should always be something of this form. If one variable changes somehow, the other variable will do this. And when you're saying it'll change, be really specific. Don't ever say, we'll be able to measure the other variable. That's crazy. You want to say it will vary specifically, so say how it's going to change, say what the constant is, if there is a constant, say what equation you're relying on. Be as detailed as you can right here in your prediction. So go ahead and get this down. And then for the actual data taking, we're bringing this gizmo back, the LabQuest, and we have a force probe. And what we're going to be doing is hanging different masses on that force probe, recording their mass, and then measuring the weight in newtons on here. So go ahead and pause the video for a sec, get down all of this, get down your hypothesis, get down your apparatus, your sketch for that, and copy down this data table. We'll be back in a minute with data. All right, we're back with data. So we filled in the values for mass we're going to do. Quick little word of warning though. All of the values on these things, let's see if y'all can read that. Those all say grams. So we don't care about grams in here. That's more of a chemistry thing. We're converting everything to kilograms, dividing by 1,000, moving the decimal 3 over, so 50 turns into 0.05. But the way we're actually going to take this data, like I said earlier, we hang the mass, we read the number off of this. Now you can see right now that it's kind of fiddling up and down a little bit. You can see that the mass is swaying on the hook, and there's just a little randomness in everything. So hint, hint, a little bit of error there. This is hovering around, I would say 0.49. 0.49 is the number that's showing up the most, and it's kind of the center of the data. So that's our first value. Next we have 100. That's going to give us 0.95. So again, notice how I'm reading that. It's going up and down a whole bunch. You got to pick the point in the middle. Then we have 300. See if I can do this without dropping the weights everywhere. This gives us 2.95. Well, I made it to trial 4 without dropping the weights. Now we're at, for 0.4 kilograms, we are at 3.9 newtons. Notice also as I'm going through and measuring, this is going to be 0.5 kilograms. As I'm doing this, I'm sometimes ignoring the numbers at the end. If it's changing way too rapidly and you can't really get a reliable value, just pick the one it's closest to. This, I'm saying it's hovering at 4.85. What am I doing next? 750. Got 500, a 200, and a 50. It's fun, huh, guys? Thinking we'll edit some of this out later. Okay, so for 0.75 kilograms, we are at 7.3 newtons. Now for 800, 7.8. All right, now for the fun one. You'll probably have to wait a bit for this one. Get comfy. Go get a drink. So for 0.95 kilograms, we are at 9.2 newtons. That one was on purpose, doesn't count. For 1 kilogram, hovering right at 9.75. And then, last but not least, actually greatest, we have 1.2 kilograms. Force sensor is showing, we'll say 11.7 newtons. All right, so you've got your data, you've got your pre-lab, you've got everything you need to do the pre-lab. Remember that somewhere in there you need to have a list for your procedure. So what steps did we do to go through and take the lab? Remember to include any calculations you think we're going to make, any steps we took to minimize error, and anything we had to do to get the lab and get to this. See you tomorrow. So we were just thinking, and we're going to throw something else at you. We were talking about how this is wiggling up and down a little bit. This is a great way for us to introduce the idea of error bars to you. Basically, including some sort of error that you have in your lab, some sort of random thing happening on your graph. Now, for the mass, the mass is just the mass. It's written right there. So we're going to assume there's no variance there. So for our error bar for the mass, for the horizontal axis, there won't be one. That's a plus or minus just 0. No weirdness there. But here, once that stabilizes out, you can see that that's not really varying by much more than 0.05 either way, above or below 11.7. So our error bar for the weight is going to be plus or minus 0.05. So what we're saying there is that our data is somewhere in between 11.70 plus or minus that error. So we're going to include that on our graph. Don't have to do much with it right now. Just make sure you get it on your data table. See you tomorrow, for real.